Hi, this is Kenneth Wong, editor for DE Magazine. Welcome to another episode of our podcast. Glad to have you along. States and businesses are reopening in various degrees, many tiptoeing into the new normal of social distancing while running design and engineering projects. We think it's time to take a fresh look at digital twins or digital counterparts of cars, planes, and factories connected to real-time updates. So joining me today is Samir Kar from Ansys. Samir, welcome, and will you introduce yourself and tell us what you do at Ansys?
Yes, absolutely. Thanks, Kenneth. It's a pleasure being here. My name is Samir Kher, as you mentioned. I'm a senior director at Ansys. I head up all of our digital twin activities at Ansys, which is, if you know, the world's largest simulation software company.
Very good. So, digital twins, are they relevant now that people are emerging from lockdown? And if so, in which context, how?
Yeah, so as you mentioned, Kenneth, digital twins represent these virtual replicas of physical equipment, and they're typically used in predictive maintenance and for optimizing operations. So in fact, in the current scenario, they are actually more relevant than ever. At Ansys, in fact, we're seeing increased interest and investment from our customers around digital twins. And I'll mention a few of the applications where we see digital twins being used. So, for example, things like remote monitoring of equipment, which obviously helps with social distancing, being able to perform activities like increasing throughput for certain items and then reconfiguring factory lines to meet changing demand. So, for example, being able to manage for the increased demand and things like hand sanitizers and so on. These applications really require the availability of simulation-based digital twins, and that's effectively the only way to achieve what customers are looking for.
Suppose a manufacturer or an engineering firm wants to put together a digital twin. What would you say are the basic ingredients? What sort of things do they need to put together a digital twin to start doing that kind of predictive maintenance things that you mentioned?
Mm-hmm. To build a good digital twin, you can choose from a variety of ingredients depending on what you have access to. And a good recipe does rely at its heart, at its core, on solid engineering knowledge. Typically, this engineering knowledge is codified as simulation models. So that's an important piece of this recipe. In order to build these simulation-based models, you can either rely on existing simulations that customers have access to as part of their design, product design, or you could construct new engineering simulation models based on diagrams, schematic diagrams, and PNIDs and things like that. The next step is to take these models and then convert them into a form that can be scaled and deployed. And then these deployed models should be augmented with analytics and then be driven by real sensor data coming from the real equipment, either real time or offline. And then finally, of course, this twin needs a place to live. It can be ported either to the cloud or on the edge. And then once you have this recipe with all of these ingredients, you're able to use your digital twin as a virtual replica of your equipment and then use it to better maintain and operate your equipment.
So some people say, yeah, sure, I have all these standards, but some of them lives in my ERP, some of them in my PLM, some of them in my FEA program. And some of your partners actually are proposing using, for example, AR, VR, augmented reality or virtual reality goggles as a way to consolidate all of them and look at them inside these. What would you say are the kind of an ideal environments in which you can visualize digital twins and play what if scenarios?
Sure, and there is no single answer to it necessarily, but at Ansys, we believe we've come up with a unique product. It's called Ansys Twin Builder. This product we've built so that you can quickly build, validate, and deploy your simulation-based digital twins using all of the ingredients that you mentioned and the ones that I mentioned in the previous answer. When hosting these digital twins, so where they live, twins can live either on the edge or on the cloud. And then depending on the hosting infrastructure, you could either decide to use an existing platform, like an existing IoT platform. Companies like SAP and PTC and several others have existing IoT platforms that you can reuse. You could also build your own using infrastructure companies and capabilities that companies like Microsoft provide. So, for example, Azure Digital Twins, which they recently released. And then if you want to deploy to the edge, you can use hardware and software stacks from companies like Rockwell Automation or, again, Microsoft. Our solution actually deploys to all of these, and we're pretty agnostic.
Okay, thank you very much, Samir. There is a panel discussion on digital twins with speakers from SAP, PTC, Ansys, Microsoft, and Rockwell Automation at the upcoming Ansys Simulation World, which is actually moderated by me, Kenneth Wong. There is also the upcoming Case 20 Simulation Conference that is sponsored by Ansys and supported by DE as a media partner, and digital twin is a dominant topic in these tracks. So if you want to learn more about these topics, I hope you tune in to hear more about the topic. Thank you very much, Samir, for sharing your thoughts with us.
Thanks, Kenneth.
All right, I'm Kenneth Wong for DE. We are out. See you next time.